In this video, we're going to be solving a Unit 4 FRQ for AB Physics 1. So, let's start off with question 1. Two blocks are on a horizontal tabletop as shown in the figure. Block A of mass MA is initially moving with speed V initial to the right toward block B of mass MB, which is initially at rest. The blocks can slide with negligible friction on the tabletop, which is the height h above the floor. The blocks collide and stick together, moving to the right and beyond the edge of the table. The blocks remain together as they fall to the floor, landing with their center of mass in a horizontal distance delta x AB from the table's edge. Block B is then returned to its initial position, and block A is then replaced with block C. Block C has a mass of 2 ma and is given an initial speed of v initial divided by 2 to the right. As a result, the blocks collide together and remain together. As they fall to the floor. Blocks B and C land with their center of mass a horizontal distance from delta x BC from the table's edge. Indicate the correct relationship between delta x AB and delta x BC. So, what we know is that after the collision, the blocks leave the table horizontally. So they leave horizontally post collision, and the time to fall depends only on h. So time to fall depends only on h. Therefore, the horizontal distance depends only on horizontal velocity post collision. So what we're going to do is we're going to compare the post collision horizontal speeds. So now we know block A, that's MA, block B, MB, and then the initial speed of A, that's going to be V initial, and then block B is at rest. So then they stick together. So that's perfectly inelastic collision. And now because of this, we can use the conservation of momentum because there is no net horizontal forces. So that means that you can use the conservation of momentum. So that's going to be MA, mass of block A times the initial speed times, now both blocks are stuck together. So this is going to be a new mass. This is the total mass. That's VAB. So now they're moving together. So now if we solve for the post-collision speed, we want VAB. That's going to be VAB is going to be equal to MA over MA plus MB times V initial. Now for block C and B, we know block C, the mass is 2MA. C mass. And we know the initial speed of the initial speed of C is V initial over 2. And block B is at rest initially. Block B. Okay, so this is for block C. So for block B, so then we know that after this, they stick together. So if they stick together, then we can use conservation of momentum. And what that means is that we have 2MA times V initial divided by 2 is going to equal to 2MA plus MB times VB, the velocity of B to C. So then if we simplify this, we can cancel out that 2, and we can rewrite this as MA, V initial is equal to 2MA plus MB times VBC. So VBC dividing both sides, that's going to be MA over 2MA plus MB v initial. And now we can compare the speeds. So we have, this is 1 and this is 2. So which one is larger? So we have, so we know that MA plus MB is going to be larger because the denominator, because it's divided by a smaller number. So this is a 2, so that means we can write MA plus MB greater than MA over 2MA plus MB. That's because the denominator is larger. Therefore, entire number is smaller for this portion. So then we can write VAB is greater than VBC. So this is going to be this one. Now, what else do we want to find? Well, we can also justify this using the time of fall. So if we were to find the time of fall, we know that vertical motion, it starts from rest. And because we know it starts from rest, we know the formula h is equal to 1/2 gt squared. Now, if we were to solve for t, we would get t is equal to the root of 2h over g. And this is actually the same for both cases, because they start from the same height. And that means that we have that if you have the same h, then you have the same t, because we can see that they are linear. Okay, we can see that they are linearly related. They're directly proportional. So, and we can also see if we calculate the horizontal distance. If we calculate the horizontal distance, we can see that delta x is equal to v horizontal times h. And we know that since we know that t is the same, and we know that VAB is going to be greater than VBC, then we can conclude that delta x AB is going to be greater than delta x BC. So those are two other ways to back up that solution. Now, let's start off with part B. Starting with the conservation of momentum, derive an expression for delta x AB in terms of MA, MB, V initial, H, and physical constants as appropriate. Assume the time during which the blocks are only partially beyond the table's edge and still partially on the table is negligible. So we're asked to start with the conservation of momentum. So what that means is, so we had a collision, right? But we know that before the collision, we know that only block A is moving. And because of that, then we can write that P initial is equal to MA V initial. But then we know that after the collision, we know that the blocks, they stick together. And because we know that they stick together, we can write that PF is equal to the total mass of the blocks that are stuck together now. And because they're moving together, one item, it can only have one velocity, so that's velocity VAB. Now, we can set them equal. So if we set them equal, yes, we can write, we have the initial equal to P initial is equal to, P initial is equal to PF. So that is MA V initial is equal to MA plus MB VAB, right? So now if you solve for VAB, we have VAB is equal to MA over MA plus MB. So that's not V initial. Now, if we were to calculate the time to fall off the table, we know that when you are falling off the table, we know that vertical motion is only affected by gravity. And because of that, we know h is equal to 1/2 gt squared, which we used before. Now solving for time again, t is equal to the root of 2h over g. Now, if we were to find the horizontal distance traveled, well, we know that the horizontal speed is constant after leaving the table, and that's because we have the beyond the table's edge, because assume the time during which the blocks are only partially beyond the table's edge and still partially on the table is negligible. So that time is negligible, and we can see here that there is no friction, negligible friction again, remember. So we can write that delta x AB is equal to VAB times t. Now, if we were to, now we can substitute our expressions. So we know that VAB was equal to this, right? And we also know that t was equal to this. So then we know that okay, now we can write delta x AB is equal to MA over MA plus MB times V initial is 2H over G. Indicate whether the expression you derived in part B is consistent with the relationship you selected in part A. So what this is asking is the expression you derived in part B the same, and is it consistent with the inequality that we chose in part A? And then why? And we have to use that expression. So remember from part A that we concluded that delta x AB is going to be less than delta x BC. Now, our expression from part B, that was, so from part B, we wrote that delta x AB is equal to MA plus MB times V initial over 2H over G. Now, we know that all quantities except the mass term, all quantities except for the mass term are the same for both cases. Now, the expression for delta x BC, this was delta x BC, that was equal to MA over 2MA plus MB times V initial times 2H over G. Now, if we compare these expressions, we can see that they have the same factors. So we can see they both have, let's use a different color. We see they both have 2H, G, and they also have V initial. So now we just only have to look at the fractions, right? Because these are the only things that are different, right? So we know that, okay, MA over MA plus MB versus MA over 2MA plus MB. Well, we know that MA plus MB is going to be less than 2MA plus MB. That means that it follows that MA for MA plus MB is going to be greater than MA over 2MA plus MB. So therefore, we know that delta x AB is going to be greater than delta x BC. So we can say that, yes, the expression derived in part B is consistent with the relationship selected in part A, because we know that the horizontal distance is proportional to the factor MA over MA plus MB, and replacing block A with block C increases the total mass post collision, which increasing the denominator and decreasing the horizontal velocity. Since the time of the fall is the same, cases, the reduced horizontal velocity results in a smaller horizontal distance. So delta x AB is greater than delta x BC.